This last question is a particularly challenging one because we're talking about finding an equation of a line that is perpendicular, and we also have variables in this equation or this graph. Okay, so how do we first of all give us a picture that we can work with? Well, we can still graph this because we know that we're 2 along the x, and although it's negative a along the x, we know proportionally that's going to be relative to 3a over here. So 2 over, we're going to go a down, so we're just going to say that that's negative a, and that's 2. And we go 7 over, so 7 somewhere out here, and then we're going to go up 3a, so that's going to be about 3 times the height of the distance between from 0 to negative a. We're going to go the opposite direction, 3. So although it's kind of hard to know what a is, we know proportionally it's going to look like this, so we're okay. Now we are going to still have a's in our rise and run here, because our rise here between 3a and negative a is going to be positive 4a. And our run we can measure as positive 5. So when we work out the slope, our slope will have an a in it, rise over run. Okay, so we're going to have to kind of deal with that. So we want to know the equation of not this black line I've drawn, but the perpendicular line here through this point of 2, negative a. So I need to know the slope of that perpendicular line. And I have a point, so I can actually just plug it in and work out the point slope form of that. But really I just need the slope of the perpendicular line. So the slope of the perpendicular line is going to be the negative reciprocal. So I'm going to flip that upside down and make it negative. So instead of going up in this direction, it's going to go down in this direction. So I now have the slope of that line. And if I have the slope of the line, well, I just need some point on that line to be able to write it in my point slope form. So there it is. There's my point slope form of that equation. Okay, I have the slope of the line. I use the coordinate that is on the line. I know there is a point on that line at 2, negative a, so I can plug that into my point slope equation. I can make this into y equals mx plus b by expanding out those brackets and combining like terms. So I end up with negative 5 over 4a x plus 10 over 4a minus, and let's make this, well, let's just make that a, and then we'll combine those like terms. So we end up with negative 5 over 4a x plus 5 over 2a minus, we'll just make that 2a over 2a. So then this simplifies to y equals negative 5 over 4ax plus 3 over 2a. And there is the same equation. Okay, that is the same as the green equation that I've written, but this now is in slope-intercept form. So this is actually better, I think, because we don't really need to worry about finding the y-intercept and doing all this algebra. We have our slope and point, and that's good enough for the point-intercept.